metric designator is a number that indicates the nominal inside diameter, or ID, of a conduit in millimeters. A 1/2 inch trade size conduit has a metric designator of 21. This means that a 1/2 inch trade size conduit has an inside diameter of approximately 21 millimeters. Conduit sizing is a crucial aspect of electrical installations, ensuring that the correct size of conduit is selected to safely house and protect electrical conductors. The National Electrical Code, or NEC, provides guidelines and tables for determining the appropriate conduit size based on the number, type, and size of conductors being installed. Conduit comes in various trade sizes, which are expressed in inches, such as 1/2 inch, 3/4 inch, 1 inch, and so on. However, in many parts of the world, including countries that use the metric system, conduit is also designated by a metric designator. The metric designator is a numerical value that represents the nominal inside diameter of the conduit in millimeters. Understanding the relationship between trade sizes and metric designators is essential for electrical professionals working in diverse environments or dealing with projects that involve both systems of measurement. The NEC provides tables that cross-reference trade sizes with their corresponding metric designators, allowing for easy conversion between the two systems. For example, a 1/2 inch trade size conduit has a metric designator of 16, which indicates that its nominal inside diameter is approximately 16 millimeters. Similarly, a 3/4 inch trade size conduit has a metric designator of 21, corresponding to an approximate inside diameter of 21 millimeters. When selecting conduit size, it's crucial to consider the fill capacity of the conduit, which is the percentage of the conduit's cross-sectional area that can be occupied by conductors. The NEC specifies maximum fill percentages for different types of conduit and wiring configurations. Exceeding the fill capacity can lead to overheating of conductors, difficulty in pulling wires, and potential damage to the insulation. To determine the appropriate conduit size, electrical professionals typically consult the NEC tables, which provide information on the allowable number of conductors of a given size and type that can be installed in various conduit sizes. These tables take into account factors such as conductor insulation type, conduit material, and whether the conductors are all the same size or a mixture of sizes. In addition to the fill capacity, it's also important to consider the bending radius of the conduit when making bends or offsets. The NEC specifies minimum bending radii for different types of conduit to prevent damage to the conduit and conductors. Sharp bends can cause the conduit to kink or collapse, reducing its internal diameter and making it difficult to pull wires. The choice of conduit material also plays a significant role in electrical installations. Common conduit materials include rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or IMT, and rigid polyvinyl chloride, or PVC. Each material has its own advantages and disadvantages in terms of cost, weight, corrosion resistance, and mechanical strength. RMC is typically used in applications where high mechanical strength and corrosion resistance are required, such as in direct burial or exposed locations. IMC is a lighter weight alternative to RMC and is often used in similar applications. EMT is a thin-walled conduit that is commonly used for concealed wiring in dry locations. PVC conduit is lightweight, corrosion-resistant, and non-conductive, making it suitable for underground or corrosive environments. Proper installation techniques are essential for ensuring the safety and reliability of electrical conduit systems. This includes using the correct fittings and connectors, supporting the conduit at appropriate intervals, and grounding the conduit system in accordance with the NEC. Fittings and connectors should be listed and labeled for the specific type of conduit being used. Support should be installed at intervals that prevent the conduit from sagging or becoming damaged. Grounding the conduit system is crucial for providing a safe path for fault current to flow back to the source, minimizing the risk of electric shock. In summary, conduit sizing is a critical aspect of electrical installations that requires careful consideration of factors such as conductor size, conduit fill capacity, bending radius, and conduit material. The NEC provides comprehensive guidelines and tables for determining the appropriate conduit size and ensuring the safety and reliability of electrical systems. Understanding the relationship between trade sizes and metric designators is essential for electrical professionals working in diverse environments or dealing with projects that involve both systems of measurement. Always consult the latest edition of the NEC and follow local codes and regulations when designing and installing electrical conduit systems. Additional considerations for conduit installations include the environment in which the conduit will be installed. For example, in wet locations, such as underground or in areas subject to frequent moisture, it is important to use conduit and fittings that are listed for wet locations. These fittings are designed to prevent water from entering the conduit system, which can cause corrosion and electrical hazards. In corrosive environments, such as chemical plants or coastal areas, it is important to use conduit materials that are resistant to corrosion, such as PVC or stainless steel. These materials will help to protect the conductors from damage and ensure the long-term reliability of the electrical system. Another important consideration is the type of conductors that will be installed in the conduit. Different types of conductors have different insulation ratings and temperature ratings. It is important to select conduit that is suitable for the type of conductors being used. For example, if using conductors with a high temperature insulation rating, it is important to use conduit that is also rated for high temperatures. This will prevent the insulation from breaking down and causing a short circuit. In addition to the NEC, there are other standards and regulations that may apply to conduit installations. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for conduit and fittings. These standards provide guidance on the design, testing, and performance of conduit products. Local codes and regulations may also have specific requirements for conduit installations. It is important to check with the local authority having jurisdiction or ODG to determine the applicable codes and regulations. Proper planning and design are essential for successful conduit installation. This includes determining the route of the conduit, selecting the appropriate conduit size and material, and planning for any necessary bends or offsets. It is also important to consider the accessibility of the conduit for future maintenance or repairs. The conduit should be installed in a location where it can be easily accessed without having to remove other equipment or structures. Before starting the installation, it is important to verify that all of the necessary materials and tools are available. This includes the conduit, fittings, connectors, supports, and grounding equipment. It is also important to have the proper tools for cutting, bending, and threading the conduit. Safety is always the top priority when working with electrical conduit. It is important to wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and a hard hat. It is also important to follow all safety procedures and precautions. Before working on any electrical equipment, it is important to de-energize the circuit and verify that it is de-energized using a voltage tester. When cutting conduit, it is important to use a proper conduit cutter or saw. Avoid using a hacksaw, as this can leave sharp edges that can damage the conductors. When bending conduit, it is important to use a conduit bender that is designed for the size and type of conduit being used. Avoid using excessive force, as this can damage the conduit. When threading conduit, it is important to use a proper pipe threader and cutting oil. This will ensure that the threads are clean and accurate. After the conduit is installed, it is important to inspect it carefully to ensure that it is properly supported, grounded, and free from damage. Any defect should be corrected before the conductors are installed. When pulling conductors through the conduit, it is important to use a pulling lubricant. This will help to reduce friction and prevent damage to the conductors. It is also important to use a pulling rope or tape that is strong enough to handle the weight of the conductors. Avoid pulling too many conductors at once, as this can make it difficult to pull the wires and can damage the insulation. After the conductors are installed, it is important to test the circuit to ensure that it is working properly. This includes checking the voltage, current, and continuity of the circuit. Any problems should be corrected before the circuit is put into service. Regular maintenance is important for ensuring the long-term reliability of conduit systems. This includes inspecting the conduit for damage, corrosion, or loose connections. Any problems should be corrected promptly. In addition to visual inspections, it is also important to perform periodic testing of the grounding system. This will ensure that the grounding system is still effective in providing a safe path for fault current to flow back to the source. By following these guidelines, electrical professionals can ensure that conduit systems are installed and maintained safely and reliably. This will help to protect people and property from electrical hazards. Remember to always consult the latest edition of the NEC and follow local codes and regulations when designing and installing electrical conduit systems. Understanding the different types of conduit and their applications is crucial for selecting the right material for a specific project. RMC, known for its heavy-duty construction, offers excellent protection against physical damage and is often used in exposed locations where the conduit is susceptible to impact. IMC, while similar to RMC, is lighter in weight, making it easier to handle and install. It is commonly used in commercial and industrial applications where a high level of protection is required. EMT, a thin-walled conduit, is a popular choice for concealed wiring in dry locations. It is lightweight, easy to bend, and provides adequate protection for conductors. PVC conduit is a non-metallic option that is resistant to corrosion and chemicals. It is commonly used in underground installations and in areas where exposure to moisture or corrosive substances is a concern. Flexible metal conduit, or FMC, and liquid-type flexible metal conduit, or LFMC, are used in situations where flexibility is required, such as connecting to motors or other equipment that may vibrate. FMC is suitable for dry locations, while LFMC is designed for wet locations and provides a liquid-tight seal. The selection of the appropriate conduit fittings and connectors is just as important as choosing the right conduit material. Fittings and connectors must be compatible with the type and size of conduit being used and must be listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. Proper installation of fittings and connectors is essential for ensuring a secure and reliable connection. When making conduit bends, it is important to use a conduit bender that is designed for the specific type and size of conduit. The bending radius should comply with the NEC requirements to prevent damage to the conduit and conductors. Supporting the conduit at appropriate intervals is crucial for maintaining its structural integrity and preventing sagging. The NEC specifies the maximum support spacing for different types of conduit. Grounding the conduit system is essential for safety. The conduit should be properly grounded in accordance with the NEC to provide a low impedance path for fault current to flow back to the source. This helps to protect against electric shock and equipment damage. When pulling conductors through the conduit, it is important to use a pulling lubricant to reduce friction and prevent damage to the insulation. The pulling force should be limited to prevent stretching or breaking the conductors. After the installation is complete, it is important to inspect the conduit system to ensure that it is properly installed and that all connections are tight. Any defects should be corrected before the system is energized. Regular maintenance is essential for ensuring the long-term reliability of the conduit system. This includes inspecting the conduit for damage, corrosion, and loose connections. Any problems should be corrected promptly. By following these best practices, electrical professionals can ensure that conduit systems are installed and maintained safely and effectively. This will help to protect people and property from electrical hazards and ensure the reliable operation of electrical equipment. Always consult the latest edition of the NEC and follow local codes and regulations when designing and installing electrical conduit systems.